So in this VR clip, I'm actually going to showcase how to set up a really simple teleportation system in your VR projects. Now, teleportation is usually offered as an alternative movement mechanic for most VR apps. So usually you can just use your joysticks on your touch controllers to move around your environment, or you can actually physically step around using like your own feet to actually move through your rooms. But of course, that comes with the limitation of you being limited by the amount of space you have available. Now, teleportation is really great for not triggering the virtual reality sickness or the motion sickness that most people might experience when they're putting on the headset and trying to move around, which is why you know most apps actually offer that option. Now, essentially, teleportation is just taking the position of your avatar object and then directly modifying that during runtime based on user input within a custom script. Now, what really the main thing that you have to worry about is how you're actually going to implement that based on your interaction design. Now, if you're on an FPS controller setup, so you're using mouse and keyboard, the probably the easiest way to implement this is if you just teleport directly based on where your camera is currently looking at. So, say if I point my red dot in the middle of the screen, in front of that cube plus sphere object, and then press right click, I can actually instantly teleport right there. And yeah, so it's basically just based on where your FPS controller camera is currently looking, and you can use the red dot as a guide. So I'm actually going to showcase how I set that up in this clip. Now, again, this is just using the FPS controller setup, so mouse and keyboard. If you're doing, if you're actually using the OVR camera rig or the OVR player controller for your headset builds, you will want to do this in a different way. And I actually have a separate clip available in the Milo recording section that showcases how to do that with a headset setup instead. Yep. So ideally, you want to have your avatar, you want to have your floor or your plane object to act as your floor. One thing that you want to do, though, is while you have the plane selected, you want to assign a special tag to the plane object. So in my case, I've given it the tag floor. If you want to add a tag to the game object that you have selected, it's just a matter of selecting add tag, which should bring up this tags and layers window in your inspector window. And then just click on the plus icon and just write a new tag name that you will be using, and then go ahead and click save, and that should add that tag into your tag list. And then when you want to apply that tag to your objects, just a matter of selecting the object itself, and then again, just clicking on the drop-down menu next to the tag. And that's it. Another thing as well that I've done is that I've added a custom script. I just named it teleport 2 point, but really it's up to you how you want to name that. And I just added that I just added that directly to the FPS controller object. All right, so now with that basic setup out the way, let's actually have a look at what the code, actually does. So as you can see here, I've set up some comments so that you could actually pause the video if you want to quickly read on what each line of code does. I'm just going to go through like a basic, like a basic rundown of like the parts of the code. But again, feel free to pause the video if you want to like doubly check the method names and, the comments and whatnot. Now, for public variables, I really only have a variable for the camera object as well as the avatar for the character controller, rather, of the avatar object. And those are public, which means that you will actually want to set those values in the inspector window here on the right. So just go ahead and drag the first-person character object from the hierarchy and drag that to, hang on, I need to make sure that that's locked. Yeah, so make sure to drag the first-person character object under FPS controller to the camera variable, and then drag the FPS controller object itself to the avatar public variable in the inspector. And that should sort out those values. So we need a reference to those two game objects so that we can actually do what we need to do. Now, pretty much the rest of the code you can find inside the update method, which means that it's going to run every frame. And basically what we're doing first is we're checking to see for user input. So in my case, I'm checking if the user clicks on the right mouse button on their mouse. And if that happens, this is where we start setting up the teleportation mechanic. So first thing that we need to do is we need to create a ray. So the main way to figure out, how to because we need the exact position of where to actually teleport our avatar. So where to set the position value of the avatar, right? And in order to do that, we're going to be doing what's called a ray cast. Now, ray casting is already covered in the 3D interaction lecture by Winyu, so hopefully you guys have already watched that. But basically, we're running like a line or like a ray from the center of the screen towards basically the direction of where the camera is facing, and we're checking to see if there's a collision, on that ray that we're casting. Now that's exactly what this first line of code does. It just creates a new ray, and then it sets it up so that the starting point of the ray is actually coming from the center of the screen. So that's again where the red dot comes in here, and we're basically directing that ray forward. So like in the forward direction, so where the camera is facing. We also need a raycast hit variable to store the result of that raycast. If we don't get like any collisions whatsoever, this variable is going to be empty. Otherwise, it's going to contain something which we'll be using for like getting the result. And then once we have those two variables set up, we then do a physics.raycast method call. So this is the actual method that does the raycast itself. We just provided the ray object that we've created from like the first earlier line, and then we're outputting the results of that raycast to the hit variable right here. Now, this is basically saying, if something actually collides with the ray, we can then proceed with the next bit of code right here. And if it does collide something, the first thing that we do is we actually check if the collision is actually with the floor object. So this is what this does. So hit.transform.tag is equals to floor. So ideally, when we're actually doing the teleporting, we don't teleport the avatar when it's not actually, aiming at the floor, because you don't want to teleport the avatar when it's when it doesn't really have like that exact sort of direction of where to actually head towards. So we're just restricting the teleportation to only happen if we're actually aiming on the floor, which is why we needed that floor tag from earlier. All right, so once we've ascertained that we're actually aiming at the floor, we then go ahead and proceed with the last bits of code here. So first line is we're actually disabling the character controller. So that's the character controller we stored from the avatar, which we got a reference from in the inspector here, this one. And the reason why we're disabling that, as you can see here, is because we want to make sure that the movement logic from the character controller script isn't going to overwrite our teleport. So basically, the first-person controller script here actually calculates its own like movement direction every frame, and we just want to make sure that we turn that off when we actually do the teleport, because otherwise we're just going to go back to where we started. And then next, we actually, once we've disabled that character controller, we then go ahead and actually teleport the avatar object, so the FPS controller, to the new position. And we get that new position by basically accessing the hit variable that we set up earlier, and then calling in the point property of the raycast hit. So hit.point basically means where the ray actually collided with in the object. So which point in the object did the ray hit? Yep. And then we're basically, with that new position, we're offsetting the y axis value of that by like 1, because we want to make sure that because there's, the character controller has like about a height of 1, and we want to make sure that when we're teleporting the character controller, it's not actually in the middle of the ground, so like it's not sinking. Hence why we're just offsetting that by 1. And then we just override the position value of the avatar with the new position here that we have set up. And then once we've teleported the avatar, we then just turn the character controller again back on. So avatar.enabled is equals to true. And again, once you have all that set up, you will then get this teleporting behavior when you're actually pressing right click while you're aiming on the floor. Easy. Now, if you actually want to set up the red dot here, what you will need to do is you actually, if I just hide this real quick, you actually need to create a new UI canvas. So go ahead and right click on the hierarchy window, select UI, and then select image. And that should create this canvas right here. And now you want to make sure that the pivot or the anchor, the pivot is set to the center. So if we just go ahead and hold down shift, so in the inspector while you have the image selected, go to the rect transform property and then click on this sort of like crosshair looking square here on the left hand side. Now when you bring up the anchor presets window, you want to hold down shift and alt, and you want to click on the center option here, so center middle, which is this one, and that should bring the image to the very center of your screen. And now you can just go ahead and actually adjust the width of the image based on how big you want the crosshair to be. I'm actually going to go ahead and set it to 10 or maybe even 15 because that's a bit too tiny. You can also change the color to something different if you prefer. I'm going to go with like, green or something. Yep. And then if you select canvas, you want to head over to the canvas property in the inspector. And then under render mode, you want to change it from screen space overlay to, screen space overlay. You want to make sure that that's set to screen space overlay. And then in the canvas scaler property, you want to set the UI scale mode from constant pixel size to scale with screen size. And then under reference resolution, you want to change the value to like the appropriate aspect ratio. 16:9 or 4:3, or depends really on your monitor resolution settings. If you want to be safe, you're not really sure what those values, you can just go ahead and type 1920 by 1080, which is like 4:3. And that should ensure that no matter how big your screen is, your crosshair will always be in the middle of it. So now if we play again, you should be able to see the green crosshair now. And if you notice, if I resize the window, the crosshair will always stand in the center of the screen, which is what we want, especially when we want to make sure that we're teleporting the avatar in the middle. And that's it. Hopefully that helps you out. And yeah, see you guys next time.